Well, greetings and salutations, everybody. Um, I've been on night shift all week, and what do you call it? I was trying to cut this as an actual produced video, but I'm just it's taking an exorbitant amount of time, so I'm just going to do this as a live stream because it's not going to require that much attention. Anyway, we've been pestering Bev for about a month. Well, a month? Yeah, I'm sorry, months, plural. And they and Bev just refuses to outline his test, or at least he did. And last night, he was on Ranty's show, and in the first about 15 minutes of the show, he outlined what his test is, and I'm going to show you that he's actually designed his test with geometry in mind to produce a result deliberately that will only be called flat. He's done this on purpose. This is deliberate. So, but since he likes to always bring up my water tests, I'm just going to do a quick rundown so it's all in the same video. I had a much longer thing that I was going to say on this, and oh my god, the amount of audio that I had to cut for it, but I just said screw it. We're just not going to do that. I'm just going to run down my tests real quick first, because mine are the easiest ones, and they're all pretty much the same. I have 3 versions of the same test. We all know it. Let me go ahead and show you this here. Everybody can hear me, right? And everybody can see everything. All right, so this was the bug test 1 that I originally did. This is the one that I had the Indiegogo funding campaign for, and I still have all of the equipment and all of the tubes. All the tubes are down in my basement, taking up half of my basement space. Anyway, just to show you what it is, these are 16 upright, this was the first one, 16 upright tubes, all connected together. And the purpose of having all of them connected together is to make it into one unified level of water. And then at the very end of it, have a camera looking down the tubes while they're all in a straight line. And because of the fact that they will be looking down the tubes, it will be able to easily be observable if there's curvature to the water or not. And before I hear anything about this, because of the tangent, this camera is not looking over a hump. This is not a hump. I know it's commonly referred to as a hump, but it's not a hump. It's actually looking down, okay? Because this is vertical. This is looking down. Okay, we covered that. Cool. But unfortunately, when I did this test, I did it in a high traffic area. There was a lot of people out there enjoying the same time as I was, riding their bikes around and running around with dogs, and my pipes got damaged, and unfortunately the test yielded no results. It yielded no results that anybody could use for flat or curved earth. I showed those and I displayed those results. Unlike Jaren, I don't delete my stuff. Anyway, yeah. So here's the Y and Z of each one of the cameras, and showing that it's actually pointing down, because when you are on a sphere, vertical is extended out from the center of the sphere. Pretty simple stuff. You're going to see these lines on all the rest of this. Then there's the bug 2. This is the one that I've been wanting to do, but unfortunately COVID has us locked down, so I can't really get the time to go do it. Or, well, should I say I'm not even allowed to go out there to go do it. And I'm not going to run down there for 4 hours to drive all the way down there just to get turned around. I'm waiting for COVID to get lifted and people to get their heads out of their asses, and we can get beyond this thing. But anyway, bug 2 is the same thing as bug 1, only instead of all of the tubes being connected, they're not connected. They are all individual water levels. Because one thing that was absolute murder last time was trying to track down those. Hey, thanks J5 Project. I really appreciate that, man. One thing that was murder on time was tracking down the leaks. Well, if I make it into individuals where I meet up all the water levels with each other, then if I make it into individuals, if one of them leaks, I'll know where the problem is. I'll know where the pipe is that's having the problem. And then I only have to search down that one pipe. 100 meters to check down isn't all that bad. 1,600 meters every single time it appears there's a leak, that takes hours. Anyway, ultimately the same test though. Looking down the pipes, one will show flat or one will show curved. That's just how you get that comparison between the two of them. And then of course there's the bug light test. Now this is one that's actually more likely to happen first. The bug light test is actually not going to use the water pipes at all. It is actually going to use the water in the canal next to it. And basically what I'm going to do on that is going to have a little boat. That little boat's going to have a measuring stick on it. And then I'm going to mark a position on there, which is going to be the height of the camera. And all I'm going to be doing basically is taking that boat and running down, making a mark on each one of the upright poles, because I can just do it with the poles as opposed to the water levels, and make a marking on these, and then be able to view those markings the same way as the other two versions of the test by looking at it from down here. Now, contrary to what Bev likes to keep on saying, and other flat earthers as well like to keep on saying, this is not an elevation difference. This area right here, this is called curvature. It is not called an elevation distance, otherwise we'd be calling it a hill. And so ultimately, all of these measurements will also be equal above the water, and then we look down the entire set to see if there's curvature or not. Pretty cool? All right, so that's how we're doing all that. Now let's move on to Bev's test. And you're going to see, I'm going to show to you that he's actually doing this deliberately, because there was also a wonderful question that was posed by the host of the show, a guy named Brandon. I don't think I've ever talked to him before. If I have, I just didn't know. And he asked a really good question. And yeah. And also at the end of this stream here, I'm actually going to be playing the whole presentation from Bev, the whole opening presentation from Bev, so nobody can say I took him out of context. But I'm going to do that at the end instead of in the beginning. So this is Bev's test. Bev has one water level with 3 points on it. This is the water level with 3 test points on it. Same thing. This is how it would look on a sphere. Now, each one of these are 100 meters. That's what he stated. He has a pipe of 100 meters. I'm going to believe him. And then what he's going to do is, this is so silly. He's going to put his auto level right in the middle. Now, this is what it would look like on either one. Obviously, this is just one test, but this is how it would look on either one. What he's going to do is he's going to bring his auto level to bear on one of the water level sides, and then he's just going to turn it around and bring it to bear on the other level side. That's all he's going to do. So basically what he's going to say is, because of the fact that he's in the middle, hey, Paul, thank you very much. Thank you. And no, we're not going to today. Basically what he's going to do is he's just going to confirm that a water level makes a water level. Zippity-doo-dah, there's absolutely nothing to be gained there. Because on a curved earth, the middle here, between these 2 points here, is actually the tangential point. Right here. I'm sorry if I keep on screwing this up, but my pen is a little bit off calibration. Sorry. So here's the point where it's actually perpendicular. So basically what he's going to be doing is he's going to say this right here and this right here are both level with the auto level, and therefore say that this is the outcome that he's getting. That's all he's going to do. And not only is he going to do it once, according to him, he's going to do it twice. And it's going to look like the same thing on both. That's his entire test. Now, The funny part is now this is what I was talking about the tangential points. You are going to get the same results of this test that he's doing on the globe and on the plane. You are going to get the exact same results. So there's nothing to be gained by this test, and Bev knows that. That's why he's doing it in the middle, because he knows that in the middle of these 2 points is the tangential point on a sphere. He knows it's there. Otherwise, he would say that he would do it out at this side, or he would do it from, over here, looking from this end. But no, he's going to do it in the middle because he knows that's the tangential point. Now, this was Brandon. Brandon was the host of Ranty's show, and he asked a rather polite and sensible question. He had asked, he said, now if we lettered these from left to right, A, B, and C. Now his question was basically formulated as, how do we know that the line here is the same as the line here? In other words, how do we know that the level of A and B and C are the same as A to C? This is what Bev did, and I'm not joking about this. Bev said that he would do a test, or you could do that determination by putting the auto level in the middle. Okay, still playing with the tangential point, but this time he's got drop to worry about. Because anybody who would actually do this test by having a camera in the middle, or auto level in the middle, would actually put it at the water level height of the one in the middle. Now, unfortunately, this is also going to be a worthless thing, even if he does try and do it, just because of the short distance, the 100 meters on each side. And I'll get to that in a second. But the short end of it is, no. What did he say? He didn't say that he's going to put it up here. What he wanted to do was find a way to confirm this, and quite quickly, I guess he's thought about this enough times, he actually said that there's going to be no difference. Now, if you look at this diagram right here, you could see, well, wait a minute, why would he have it down here? And this is why. Because he actually says in the live stream that you would just get rid of the middle one. That way, he can just have his level point in both directions by eliminating the point in the middle. Therefore, not being held accountable for the water level in the middle point. That's how you know that he is doing this in a disingenuous fashion, because he knows 100% if he were to put that up here, then he would have to at least know what kind of drop he's looking for. So, because this is the tangential point between this point and this point. And that's the part where it would be perpendicular, hence level, and that is the part where he would claim victory on it. Because he kept on saying that level points don't care about what's in the middle. He's trying to throw people off their scent. But that's exactly what he's doing. This is exactly what he wants to do. Which is this right here is this test right here is no different than this test. No different. He is deliberately doing it to be false. Because if you were to do it right, okay, as in look down the entire stretch from one side, he knows that the level of C will not be the same as the level of B or the level of A on a curved surface. So he doesn't want to test that. He doesn't want to make that comparison. But I have asked him several times, and he has avoided the very question of how much drop should he expect, because he keeps on talking about doing these things at 100 meters. Now, he keeps on saying that, oh, I'm going to do it 16 times. Yeah, but 16 times this test is 16 times this test. It is not 1,600 meters. Doesn't matter how many times you do it, unless they are all in a row and you can sight down them, which we all know he's not going to sight it. But check this out. I've asked him enough times, because if you are going to test curved Earth versus flat Earth, if you are going to test that, you have to know what it is that you're anticipating. And as I just told Kaz a minute ago, you have to actually know, you have to actually do the appropriate measurements for that which you're testing. It's not a trick. It's not a joke. You have to know what it is you're testing. Well, I did the math, and I found out that the B drop point, if this was set up perfectly on the water level at sea, the B drop point at 100 meters would be 0.78 millimeters of drop. 0.78. Or from the auto level itself, it would be 0.0004 degrees drop. So, point A, being further away, of course, at 200 meters, there would be 3.14 millimeters, or 0.0009 degrees of drop. Now, you could say, well, hey, now you got those measurements. Now you know what to look for, which would be great. This is also why we don't do this in short distance. This was an observation that I made on the same day that we were actually disproving Bev's 60-meter claim, the first photo that he ever produced from his auto level. This is 54 meters away. The surveyor staff. It's 54 meters away. Now this is just the top. The top crosshair. It's not the center crosshair. It's the top Sadia crosshair, and but it's not because I'm trying to show you the distance. What I'm trying to show you here is how thick the line itself is. Okay, the thickness of this line. If I made a little scale here, because between these blocks is 10 centimeters, or excuse me, a centimeter, and no, I was right the first time. Well, either way, I'm sorry, I'm just tired. This works out to be 1 millimeter thick at 54 meters. Now, you need to be able to get at 100 meters. You need to be able to determine that much, actually 3/4 of that. At 100 meters, that's almost twice the distance here. Now, at 200 meters, you have to get 3.14 millimeters, which is only it's about twice that thickness. Or excuse me, twice the height, which is only about 3 times the thickness on this. You need to have that level of precision. Hey, Paul, thank you very much. The latest that flat earths are arguing is drop is really just refraction. Get ready for that one. I ain't worried about that, because they keep on trying to make drop more important than hidden height, and that's just always been a thing. So basically what it is that he needs to be able to determine about the thickness of the crosshair of drop. That's what he needs to be able to get out of that, about the thickness of the crosshair, or 2 times the thickness of it at twice the distance. So, and to give anybody who's not too metrically inclined, let me just give you a simple scale. This is an SD card that we all have in our cameras and various other devices. The thickness of that, the thickness of the of a SD card, is actually greater than what he needs at 100 meters, and it's about 2/3 of what he needs at 200 meters. That's how much drop he has to see with that scope to find out if it's. He has to be able to determine that much to find out if that's what he's seeing or if he's not seeing that. And it would be real easy to say, well, I don't see it, because it's so damn small. So, like I said, as I promised, I'm going to show the, And I'm going to show Bev's clip in its entirety. Okay, it's about 9 minutes long. Sorry about this. I'm sorry you have to do this. Actually, 9 minutes and 56 seconds long. But I'm going to play this out because I need to make sure that it's in this video that I did not take anybody out of context. This is actually what was stated. So let me go ahead and like I said, this is just the beginning part. This went on for much longer, but there was no reason beyond that because that was his presentation of his test. Okay, so we'll see you on the flip side of this. Well, that didn't work. Hold on. I don't know why it wasn't going out to it. Oh, wait a minute. Hold on. Because I still have it set up for the fiber. Settings, program settings. Sorry about this. Not speakers. Yeah, it should be speakers. Why am I not seeing it on? Oh, I know why. Because desktop audio is set up for it. Sorry. Properties. Yeah, that was set up for optical. Okay. Let's see. Speakers. There we go. So now let's go ahead and play this here. Oh.
Trip today.
Cool.
So have you got that? Have you got my camera on there?
Yeah, let me just make it bigger for the audience
Make it
here.
big screen for everyone.
That's Brandon, by the way.
All right, you're all set.
Voice.
Right. So, for the people, for everybody that doesn't, may perhaps not know, like this is a water level tool. The two ends of the water level, see, they equalize always. So, put one of them at the front, one of them at the back. They will always equalize to be the same level. That's basically what a water level is. Now it's that level that's in question. That's what we're dealing with here today, and what surveyors do. So all this is a pipe, right? It's a tube with two ends on it, filled with water. This is a water level. Level being horizontal as known. So the idea of this is to show you sort of an idea of what we've got planned and what the basis of all of this is. So this water level here, this establishes a horizontal across there. So the question is how long could you make this water level to falsify the fact that it stays level being horizontal?
Thanks, Snark.
There's only 2 points. There's this point, and you draw a straight line between the two. That line would be level. So what we've got, we've got these here. This is 100 meters of pipe. So if you imagine that that 100 meters is here for this little bit, and then you lay out 16 of those 100 meters, you'd end up with 1,600 and 9 you try and end up with, which is a mile. So if you join all of them pipes up together and fill it up with water, you would end up with a level. Now, in order to check that level, you could do this. You put what we have here is this is like a site level, auto level. See that? I'm not leveling it. So this is the tool, the level, and you look through and you see a crosshair on the other end. So that's what DP's doing here. And you can turn this through 360 degrees and you would see a horizontal crosshair all the way around. It always be horizontal. So when you have your level in the middle of these 100 meters, you can check the level at this end with the level at this end with this tool. And strangely enough, you'll find out that the water level equalizes to be a horizontal that can be checked. I mean, it's pretty simple. I mean, nobody's got any problems with that, have they, or any questions? Because it's not difficult, and that's the basic of what you do.
Just wanted to answer a question that was in the chat. Sorry for pausing it. I'm sure everybody can use the break. But Paul, no, he's actually not even doing. You wrote, so he is saying that he wants to look down 100 meters and then move the start around to the new end. Actually, no. He wants to stand in the middle of 100 meters and measure 50 meters level in each direction from the tangential point. So, yeah. Anyway, let me continue on here.
The basic of what you do. So you go, imagine this is 100 meters. This is where your water level is, the junction is, and you've got a T junction that puts the water level up there, and it equalizes out. So you check that. Then you can move your auto level, pick it up, and move it this side. Move it 100 meters. Then you can level it up with this one, turn it all the way around, and check it with this one here. So you just keep doing that with this auto level, keeps moving along, and it goes all the way along to check the level at the other end, and it's a horizontal all the way across. Now, that is what it always has been to me, and it just makes logical and practical sense that is what happens in reality, and that with differential leveling, that the technique of this auto level, moving from here to here and using a back sight and a foresight, and you swap over to here, foresight becomes the back sight, and you just keep moving along. You move that level all the way from one end to the other. Just a practical procedure. I mean, and Dave will know. Rodney's here. Rodney, you don't mind speaking up? That would that be a typical technique of how you would move this level in reality? I think,
yeah, you explained it perfectly. Yeah, that's what we would do in differential leveling.
Okay. We still not got Cleary here.
I do have a question for you while we're waiting for Clary.
Go on.
So between each of the 100-meter...
Okay. Whoop. Okay, I got my mic on. All right, now this is the question from Brandon. And pay specific attention to how Bev actually answers this question.
sections. You're going to auto level, and that'll show that there's a horizontal between each post. So the 100 meters is a horizontal, right?
There would never need to be the water level, right? The water level is what we've got to do an extra test. All you would have is a staff like that, and that would be here at these posts, there and there, and you would just take a reading. one of them would become the foresight, and the other one would become the backside. And then as you moved to the next spot, these would have to be on like a pin or something locked in, you know.
Just to clarify, what he's talking about using that staff is absolutely useless. It's great for doing a 2-peg test, but using that staff is basically he's going to be checking the differentiating heights of the of whatever surface that he's on. Has nothing to do with the water level. It will not be the same checking against a water level. It's just the absurdity is just sorry.
To the next spot, these would have to be on like a pin or something locked in, you know, so that this doesn't move as you move this one doesn't move, and that one. So all you're doing is you're moving a measurement. The water level is just one step above, because what we found is that a lot of people don't. I mean, even surveyors, you ask surveyors, what would be more accurate, the water level or the auto level? They'll tell you they haven't got a clue. They don't know. There's something a bit weird going on, but I mean, this is just logical, practical sense. It just makes sense. And how long could you go and do that for? And, you know, to establish a horizontal? I'd say you could do it indefinitely, but other people like to see, as you'll find out later on, they like to sort of add in calculations of reality.
Yeah, indefinitely in 100-meter pieces.
Sure.
Did that explain it? Sorry, I may have rambled a bit then.
No. You did explain it. My only question would be, let's say each of those posts that you have on there, the 3 posts with the water level going up to the top, are A, B, and C from left to right. What's to say that A and B and C, that there's not an angle between those two? What I mean is, how do you know A and C are also on a horizontal? We know A and B would, and B and C would, but how do we know A to C is one long horizontal?
B and C, like that, right?
Yeah.
Well,
yeah.
all you do is you blank that off. And C, like that, right?
Yeah.
Well,
yeah.
all you do is you blank that off, and you make A to C. That would be your horizontal, right? The water level allows you to do that. You just don't. I mean, like in a water level,
All right, y'all caught that part, right? You take out the middle one, and then now you have the new line between A and C, ignoring A to B and B to C like Brandon asked. Let me do that one more time, because I want to make sure that part's clear, because that is actually him showing that he's being dishonest about this test.
3 posts with the water level going up to the top are A, B, and C from left to right. What's to say that A and B and C, that there's not an angle between those two? What I mean is, how do you know A and C are also on a horizontal? We know A and B would, and B and C would, but how do we know A to C is one long horizontal?
B and C, like that, right?
Yeah.
Well,
yeah.
all you do is you blank that off, and you make A to C. That would be your horizontal, right? The water level allows you to do that. You just don't. I mean, like in a water level, it's sort of the same as saying when you have this as your tool, your auto level, like you're establishing this here as a horizontal point and this here is a horizontal point, but you don't really need to establish that this is a horizontal point in the middle. Whereas the water level acts differently. The water level doesn't really care what happens in the middle. It just transfers the level from one end to the other. Now, if you blank that off, then this becomes the total distance, doesn't it?
Okay, I think I see what you're saying.
Yeah, it will become a bit more clear tonight because this is a showcase of the Kozlowski curvature conundrum.
So that's what we got. We have a useless test of 100 meters no matter how many times you do it. That's why he said you can do it indefinitely. A useless test of 100 meters where you're measuring only 50 meters of each side of it from the tangential point, if on a sphere. And not once did he say they would measure it from the side, because of the fact that he would actually have to look down. Now, unfortunately, given the short distance, the amount that he would have to look down is incredibly small. So this is, and y'all caught that, right? He said, "Oh, we'll just get rid of the middle, and now this is the line." There was no comparison made between A and B and C versus A to C, like Brandon had asked. He actually did not answer the question. He 100% avoided it by removing B. So, anyway, I don't want to make this too much more long because it's pretty much, I made all the points that I wanted to make. The distance is too short for him to be able to determine if there's any drop. His method of doing level in the middle is actually dishonest to exactly what it is that's attempting to be measured here. And the distances, like I said, are too short for the drop to even be noticeable because they would only be about the same thickness as the crosshair that's in his auto level. And if anybody's been following this at all, you've seen how he treats his auto level, so I wouldn't even care about that. I wouldn't even trust it anyway. So, that's all I got, ladies and gents. I really appreciate... Oh, wait. No, let me drop this down here. Oh, yeah. These were the amounts of drop per 100 meters. That was fun doing that. But I appreciate everybody stopping by. Make sure you all give Bev a nice big fat "you're a liar," or at least just a dishonest flat earther. And yeah, just make sure that everybody's fully aware of that. So anyway, I am pretty much out of time right now because I have to get a legal document off to Twitter. I warned somebody and they decided that they weren't going to listen, and using my likeness to promote a merchandise and monetized material. And I gave them a warning, and we're pretty much done with that. So I am taking the route that Twitter wanted me to take the first time, and I just got another email in the mail asking me if I want to take action, of which I am going to. So, ladies and gents, I really appreciate all y'all stopping by, and I am still not good enough at OBS to get the boom out, so everybody just make believe there's a boom. Y'all have yourselves a great day. Oh, and happy Thanksgiving to everybody.